So I don't have a little title up here. Let's just put it, this is section 7.5, but we're just kind of, I'll call it part B. Is that all right? Because we just didn't, yeah, this is in order to do number 7 and 8, okay? In fact, let me pause it. Let me get an example from the book. All right, let's draw the triangle now. I'll tell you what, let's go back a little bit. Let's go back. What we talked about yesterday was this. Watch. We talked about comparing two triangles to each other, okay? An altitude of one triangle to an altitude of another triangle. Or what? The median of one triangle to the median of another triangle. You follow me? So how many triangles am I dealing with here? Two triangles. Well, on this little example for the second part of this 7.5, I'm not dealing with two separate triangles. I'm only dealing with one triangle, all right? So, oh, let me get to my real example. There it is. So this triangle, I'm just taking this straight from the book, okay? Just make it look a little easy. I'm going to draw this just a little bit differently, though. What we're going to do is we're going to do the angle bisector. You can do any of the vertices right here, okay? Any of these points. It doesn't matter which one of these three you do. I'm just doing the same one they do in the book. All right, so I'm taking this vertex. I want to find the angle bisector. Does that mean I go to the midpoint of the opposite side? Not necessarily, no. Okay, do I go perpendicular to the opposite side? No. What do I do? Yeah, make sure these two angles are equal to each other. Right, I split this big angle in half. So I'm not really looking to where I'm ending up. I'm looking here. Everybody see that? I'm trying to split that angle in half. We talked about that yesterday, and it looks about, that's pretty close. Something like that. Would you agree? It's not bad. So watch, this angle and this angle. Now, how many triangles am I dealing with? I'm just dealing with that one big blue triangle. Everybody see that? That's all I'm talking about. But look what happens. This is an angle bisector. Jot that down. This is talking about an angle bisector. And look what it does. It hits the opposite side right here at this point. So it takes this side and it splits it up into two segments. Do you see it? Are they necessarily the same? No. Okay, they're not. They're not necessarily the same. Let's just call this little segment from here to here, let's call that A. And let's call the segment from here to here, let's call that B. Right? And then let's call this side of the triangle C and this side of the triangle D. We good so far? Yeah, we haven't done anything, have we? All we've done is label stuff. So what this theorem says is this. If I have a triangle and I've bisected one of the angles of the triangle, right, and it goes all the way to the other side, do you see how it's broken up into two segments here? I could compare those two segments to each other, A to B. And what do you think that's going to equal? Just off the top of your head, what do you think might be true? If I compare A to B, okay, am I going to go D to C? I'm going to go C to D. That's right, because look, the C is attached to this A right here, isn't it? So if I take A and compare it to B, I can take C and compare it to D. Does that mean A and B are equal to each other for the fifth time today? No. It doesn't mean C and D are, but the ratios are the same. If I take the ratio of this to this, it's going to be the same ratio as C to D. That means they're in what? What's the good geometry word? They're in proportion. That's right. When the fractions are equal to each other, then they're in proportion. So I could write it like this. Everybody see that? Do you see the difference between what we did yesterday and this? Yesterday we compared two triangles, didn't we? We compared an angle bisector of one triangle to an angle bisector of another triangle. This one we're just dealing with all inside one big triangle. So I bisected one of the angles in the triangle. It takes this opposite side, breaks it up into these two little pieces. I can compare this top piece to the bottom piece. Then I would compare the top side, right, to the bottom side. Make sense? You could compare it a couple other ways. And again, this is not new. This is stuff that we've been talking about here. Let's go red. Watch. I could compare A to B, C to D, or I can compare C to what? C to A. That's right. Now, if I go C to A, what would I have to do? I have to go D to B. Everybody see that? I could do that as well. And again, how do I know if that's right or not? Okay, I said I could go C to A and D to B, correct? So let's see if it's right. If I cross multiply, what do I get here? AD equals BC. What do I get here? AD equals BC. It's the same thing, isn't it? All right, so it's up to you. whatever your preference is, all right, on how you want to compare these things. You can compare them like that. We good? Let's I tell you what, let's do, I said I wasn't going to ruin the fun, but I'll ruin the fun and I'll help you do one, okay? So let's take a look at number 7. And I'll do that one for you, and I'll let you do number 8 on your own. Well, hopefully, actually, why don't you just try it? Try number 7. You should be able to do it really quick. It shouldn't take that long. By the time I finish drawing this picture, you should be finished. So give it a shot. Georgie, give it a shot. Come on, I'll let you do that long enough. So everybody should be trying it. Everybody look at number 7. Everybody should be working on it. While I'm drawing this thing out, you should pretty much be done. This is M. This is 8. This is 12. And this is 26. You guys finished? All right. How are we comparing these? Let's start with the M. Or you could start with these two. It doesn't make any difference. What would you do here? Compare this to what? To 8? All right, that's fine. Let's do it that way. So M, we'll do it down here. Compare M to 8. What would we do over here? 26 to 12. Good. 26. Oops, what am I doing? 26 to 12. Everybody see that? Watch, let me just show you a little shortcut math-wise. I mean, you could always cross-multiply and do what you've always done, okay? But let me just show you a little shortcut, see if you like this or not. You could cross-multiply, but since M's already on the top, how could you get rid of the 8 in one step? Because cross-multiply is 2 steps, isn't it? It's multiplying 2 things. That's actually kind of 2 steps. And then you have to divide by something, right? So that's like 3 steps. This one, you're basically done in 1 step. How can you get the M by itself? Times it by 8. That's right. Times it by 8. So that'll cancel out, won't it? So you have to come over here and multiply that by 8 as well. Now you got M by itself, don't you? Now you could put this into a calculator if you wanted to. But watch. Let's do it another way. Let's see what goes into what here. Let's do the 12 and the 8. What goes into 12 and 8? 4 does. 4 goes into this 3 times. 4 goes into this twice. Does 3 go into anything else up here? Does 3 go into 26? No, it doesn't. So what can we do? Let's multiply straight across. What's 26 times 2? What's 25 times 2? What's 25 times 2? It's 50, right? And then another extra 2 on there is what? 52. Does that make sense? All right. Just trying to show you little shortcuts. Again, it's not because I'm that smart. All right. They're just little tiny math shortcuts that sometimes is nice. So you could keep your answer just like that. And that would be perfectly fine. What answer did I read off? 17.3 or 17 and a third. It's exactly the same thing. Because look, 3 goes into 52 17 times, which is a 51, right? And then so it would be 17. Take 51 away from 52. That's a 1/3. So 17 and 1/3. Or if you wanted to do it in a calculator, put that into a calculator, you're going to get 17.3. And it's going to repeat. If you just round it, you just get 17.3. But look, I like this way. Why? Because I didn't even have to use a calculator for it. And I know some of you guys just can't wait to get the calculator out and start punching numbers in. All right, but me, I'm kind of opposite. If I can do a problem without using a calculator, I feel a little bit better about myself. Okay, I didn't have to rely on technology to get it. Some of you guys are perfectly fine with relying on technology. And again, I got no real big-time issue with that. But I don't know, me personally, I kind of like to get an answer without using a calculator if I can. Are there times where I use a calculator? Absolutely. Okay, if I don't want to sit there for half an hour and figure out some crazy thing, yeah, I stick it in a calculator, absolutely. But if I could do it just as quickly, okay, I'm all about the speed and getting it done, aren't you? Don't you like to get things done? Yeah. So to me, this was even faster than pulling out the calculator, taking the case off of there, turning it on, punching the numbers in. By the time I did all that stuff, I already got my answer. All right? Anyway. I don't know if I've convinced anybody or not. I doubt I have, but at least it's worth a try, right? So now I'm going to give you a worksheet again. It's still 7.5, and it's page 92. Now there is a little problem at the bottom, number 7. And look, it's about photography, so you need to do that problem. Okay, you need to read it, try it out, because it'll be so much fun because it's about photography, all right? But give it a shot. Don't just look at number 7 and say, Oh, look at all those words. I'm not going to sit there and read all those words. Come on. It's reading, for goodness sakes, okay? You're supposed to be able to read. So read it and try it. Give it a shot. Okay, I'm not expecting everybody to get it right, but I bet you could. I bet you if you really give it a shot, it's going to be very close to the stuff that we've done up here, and use the information that we've learned to actually do a word problem. That's why we learn this stuff anyway, right? To do word problems, to use it in real life. People say all the time, when are we ever going to use this? This is an opportunity to have a problem and see where it's actually being used. We good? All right. I'll let you use the rest of the time. The other class had actually a little less time than you did, and most of them finished. Okay, so you guys should have plenty of time to finish it. Then you won't have any homework tonight, and you'll be good to go. All right, so we'll be due tomorrow.